Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at coding tips for your applications. When you are in the business of developing applications, you may well have a number of applications which are very similar. So when you're starting off developing a new application which is similar to applications you've built before, it's good to build your application from a template. Templates can be accessed from the drop-down menu in the toolbar. This is a list of templates currently available. Some of the templates ship with PowerBasic itself, both in the console compiler and in the Windows compiler. However, you can add your own templates. I've created a video some time ago on template creation. I'll put a link in the description below to where you can find that on YouTube. The advantage, of course, in using templates is that it speeds up your development. With any development, you will start off with a basic requirement. This requirement may well give you most of the information you need to start coding. However, when you start your coding, it never does any harm to map out what the application is going to do, even just in comments. You can, of course, use professional or free packages to do mind mapping or Visio type diagrams, which are all good. Or, of course, you could design your application using pen and paper. As you become more experienced with developing in your language of choice, you can probably do most of this design in your head. However, once you start programming, it doesn't do any harm to sketch out in the program code what it is you're planning on doing. For example, at the beginning of your application, you may want to check any preconditions for the application to be allowed to run. For example, you may wish to check to see if the application is already running. Or there may well be some preconditions by which you wish the application only to run on a particular day of the week. We'll take this as an example. If we're going to set this application up only to run on a particular day of the week, we want to check the current day. So we can create a very simple function to determine which day we're actually on. We're looking to check to see if the day is Saturday. If it's not a Saturday, then we'll send a message to our log and we will exit the application immediately. If it is a Saturday, then we wish to log that we have started processing and then continue on with the rest of the code. So in this new checkDay function, we're passing a string which is the name of the day. And we wish to check to see whether the current day in your computer matches that or not. We can do this quite easily in PowerBasic by using the PowerTime class. We can prepare a local variable which we're calling IPDate as an iPowerTime variable. And then we can set IPDate to be equal to the class PowerTime. We can populate this variable with the current or local date and time by using ipdate.now. Next, we can test the value held within this variable to see if it matches the string we've passed in for the day name. We can do that quite easily by using the ipdate.dayofweek string, which will return the name of the day of the week. I'm forcing these to lowercase to make sure that there's no issues with the comparison of the strings. If the day name matches, we can return true, otherwise we can return false. So if we try running that application now, we'll see that it matches and processing has started. So we have successfully checked the current day against the day the application is looking for. Another thing to take into consideration with your application is to work out what data will flow into the application, how it is stored and manipulated, and then sent back out to where it came from. Say, for example, we wanted to store information in an array within our application. There are, of course, a number of ways of actually declaring an array. We can declare it as global to the whole application, in which case it is functionally accessible within any part of the application. Or we could create an array which is local only to the current function or subroutine. There are advantages and disadvantages of doing it either way. So let's assume for the moment that we're going to go down the route of having a global array. And we have declared this array at the beginning of our code. And we're calling the array by a single letter, the letter A. While this will work within your application, it's always a good idea to name your arrays to give some indication of what they are and what they're for. So I would suggest that you establish a naming convention for your variables. In this case, I have named this particular array as GA str staff data. I've prefixed the name of this variable with GA. That's G for global and A for array. The str further indicates that it's a string. Staff data is the indication to our programmers that this array contains staff data information. So anytime we see this referenced in the code, we know that it's global, we know that it's an array, it is indeed a string array containing staff data. Taking an approach like this, having a naming convention, means that your code is partially self-documenting. Having defined that we're going to have this global array, we now have to dimension it to say how many elements the array actually has, and how many dimensions. The redim command we've given here has dimensioned this array having 1000 elements. So effectively, we've hard-coded the value 1000 into this array. We may want to reference this at some other point in the code, so sometimes it's quite useful to redimension it using a constant. For example, max staff. We can define this constant at the beginning of our code, and anytime in the rest of the application you need to reference this 1000 number, you can use the constant max staff. And should at some point in the future your application requires to change the value of 1000 to some other value, there is only one line of code in the application that needs to change. Alternatively, you could actually store this 1000 value in an external configuration file, or even in a database. This, of course, would give you the advantage of being able to change the functionality of the application without changing the application itself. Therefore, the redimensioning of your array can be performed by calling a function. In this case, we're calling it getMaxStaff. So I've created a small stub function called getMaxStaff, which is returning the value of 1000. The function, of course, could get that 1000 value from a configuration file, from a database, or from anywhere else in the system that had that information. This gives you a great deal of flexibility. Having set up the global array which is going to be storing the data, we need to get the staff data from somewhere. Therefore, within our PBMain function, we're calling a new function called getStaffData. This segmented approach to coding allows you to break up the functionality of the application into smaller code functions or subroutines. And since a function can return a value, you can use this return value to determine whether the function has been successful or not. So if we're returning true to say the function has been successful and false to say the function is not successful, we can report to our log that the attempt to load the staff data has been unsuccessful. We can then exit the application immediately and not continue. So in this prototype, we can create a stub function whose job it is to return the value true. When you're fleshing out this function, you would of course populate the global array. But for the purposes of this prototype, where we're just looking to see what the application is going to do, this stub function will do nicely. And we are continuing in that mode by creating a stub function to adjust the staff array. This function will perform whatever manipulation you wish to do on the staff data. If it returns false, then this manipulation has not been successful and you can exit the application immediately. If it returns true, you can then continue on to the next section. And your final section of the code will be to do something to save the data. This will be the data you have just finished amending. And again, we're taking exactly the same approach. We're creating a stub function called saveData, which will return a true or a false. If true, then we have saved the data successfully and we can finish off the application. Should it return false, then some error has occurred, and you can save this error to the log. So in summary, what we've looked at today is a mechanism by which you can actually segment your application into different sections, each section performing a particular task, and each section returning a true or a false, indicating whether that section has been successful or not. so that the next part of your code can actually determine whether it's worth continuing or not. This, combined with a good naming convention for your variables and arrays, and a good naming convention for your functions, will stand you in good stead. After all, while the application will be quite clear in your mind once you've finished coding it, it may not be so clear in 6 months' time when you have to come back and fix something in it which is broken. Also, this self-documenting in the code is also useful for other developers who have not yet been involved in the application, and may at some point in the future have to pick it up to do support. Hopefully you'll find this helpful in your developments. However, that's it for today. Thank you for watching.